ANSYS Simulation Lecture 18, Rigid Dynamics. First of all, we drag Rigid Dynamics module onto geometry. And we'll take the default material. So we enter ANSYS mechanical interface. This problem is about a 4-bar linkage. And since it is a rigid dynamics problem, so we'll take all the members rigid model. In the next problem, we'll define one of the member as flexible. But in this problem, we'll make all the members, all the bars rigid. And also the material will take the default material structural steel. And in the rigid dynamics, there will be no mesh. So first of all, I'll delete this contact and then define my own joints. First of all, I'll define a body ground fixed joint on surface. So this is the body ground. Next, I will define a body-body revolute. For the reference surface, mobile surface, so we finish with the first joint. And then for the second joint, body-body revolute, reference surface, mobile surface. For the third joint, body-body revolute, reference surface, mobile surface. And for the last joint, body-body revolute, reference surface, mobile surface. So now we have finished with defining all the 4 joints in a body ground joint. So since we don't have to mesh, it is a rigid dynamic problem. So we'll enter tension. We'll define joint load, and we'll define load on the first joint, and it will be rotating with respect to z direction, and the type will be angular velocity, and the magnitude will change unit onto RPM. So we define it as 600 RPM. So this is the driver of the mechanism. For the result, we'll probe for the position of a member, and the software will calculate the center of mass position of the bar. Now we'll probe the position for point, this point, for example. And also we probe for velocity of certain point, also this point. And the acceleration of a point. So now we can go ahead and solve for the rigid dynamics problem. And in a rigid dynamic problem, we get positions, velocities, and accelerations of a mechanism. So this is the center of mass of a member. And we can see the contour of the center of mass. And for the position of the point, the velocity of the point, we have the x component, y component, and z component of the velocity at the point. And the acceleration of the point, we also have 3 components of accelerations. So in this problem, we are dealing with a rigid dynamic problem, and we get the position, velocity, acceleration, and also the reaction force of joints. In the next problem, we will define one of the members as flexural, and we'll calculate flexural dynamics for the member, and we'll get stress, strain, and also the deformation of the member.